Okay, thank you all for attending this conference talk on Let's Make XE UITest Great Again using Localhost. So my name is Kenneth. This is my profile, my email, GitHub page, Medium blog, and my LinkedIn profile. About me, I am currently a principal software engineer at SP Digital, and I like to bring agile development into the iOS space. I'm also a Tech Talk contributor in the iOS Dev Scout meetup group. So some of you guys who are working and living in Singapore may find me familiar. So I have been giving talks at our meetup group. Basically, two kinds of talks. One category of talks is about testing on iOS apps, and another category is on hacking iOS apps. When I mean hacking, it's really about teaching you how to write Swift code and hack your Pokemon Go. And today, I will be focusing on testing, and in particular, XE UITest. Now, show of hands from the audience, how many of you guys write unit tests? Nice, good. Okay, now show of hands, how many of you guys use XE UITest? Nice, great. And for the rest of you guys who didn't raise up your hands, if you and your organizations are interested to embark on XE UITest, this talk will showcase exciting insights for you to bring back. So XE UITest was launched in 2015, and it became available as a test target in Xcode. It was an amazing milestone because XE UITest can now be written with native iOS languages like Swift. And since then, XE UITest has become Apple's recommended iOS UI automation tool. It is not difficult for us to write an XE UI test case. So all you need to do is to create a Swift file and set up the following code. Import XE test framework, and then set up your XE test case class. You add your test function, and in your test function, you have to create an instance of XE UI application, and then we add interaction codes that simulate the user behavior on the app. And lastly, we write our assert statements to verify our expectations. So it's that easy. With this setup, we can easily create end-to-end XE UI tests and run them in test and even production environment. But running end-to-end tests has its issues. Firstly, we need to ensure all dependencies such as the server, database instance, third-party mobile services are properly set up before we run the test. And then some tests may require specific environment settings which may not be easy to set up, and hence the difficulty in writing such tests. There may be concurrency issues, as our tests may be using or consuming shared services. There may also be repeatability issues. Some of our tests may mutate shared services, and hence we may not be able to get the same result if we were to run the same test again. So even if we can write our XE UI test, we may not be able to achieve comprehensive UI automation test coverage. Now let's take a look at iOS testing using the test pyramid. So at the top of the pyramid, we have functional UI end-to-end test. At the middle layer, we have integration test. And at the bottom of the pyramid, we have unit test. For most iOS development setup, developers will use XE test to write unit test, and XE UI test for end-to-end end-to-end UI test. But we know that writing end-to-end test alone won't be able to provide us with good test coverage. And here, I would like to recommend two categories of integration tests for you guys. The first is mobile contract test, and the second is mock response test. The general setup for a mobile app is the app and its interaction with a server. In mobile contract test, we will mock the app and test the API interaction against the server. An example, we can run a series of curl commands that simulate a use case and assert that the server is working as expected. This kind of test usually checks for the schema and sometimes the data, the contents of the response. If the mobile contract test fails, no point going up the test pyramid and run our end-to-end test, because the failure in the mobile contract test has proven the point that something in the back-end system is not working properly. So in mock response test, we are going to flip it around. We will mock the server and assert how the app behaves. One way to set up mock response tests is to use Localhost, where we basically create a web server in the test runner. So to know more about mobile contract test, you can catch the talk which I previously given at Agile Singapore Meetup Group in November last year. The video is available on Engineers.SG. For mock response tests, just stay tuned. I will share more about it on how we can marry UITest and Localhost together. Now I will show you how easy it is for you to create Localhost test. So you just need to remember these 4 basic steps: L, A, I, and M. L, A, I, M. So L stands for localhost. We are going to set up an in-memory localhost server. And A stands for API. We are going to redirect our API calls to the localhost server. And I stands for info plist. We need to patch our info plist. And M stands for mock. We are going to set up our mock responses. So you don't need to take photos here, because I'll be sharing the links to the slides. Okay? So LAIM. So I just shared the steps. What is the first step? What's the first letter of the steps? Can anybody shout out? The letter L. And L stands for localhost. We are going to set up an in-memory server in the test runner. And because setting up a localhost is just like setting up a web server, we will need to assign a unique port number, and then we will set up and tear down the localhost server when we execute each test. So this is an example of how to set up localhost in your codes. First, we import our friend XDTest framework, and then we create our XDTest case class. And here we import a library, Swift localhost. This is the CocoaPod library written by me. It encapsulates the complications of creating a localhost server. And in our test case class, we create a property localhost. In the setup function, we are going to instantiate the property with the localhost server class assigned with a port number. And then we'll tell the localhost server, hey, start listening. In the teardown method, we will tell the localhost server to stop listening. However, using a fixed port number may not be ideal, as it prevents us from running our test in parallel. So instead, we are going to use the class function, instantiate using random port number, to assign the next available port number for use. So after L, the next letter in our setup flow is the letter A, and A stands for API. So here we are going to redirect all our outgoing API calls to hit the localhost server. Here we need to update our URL domain to localhost assigned with the port number. So just a simple illustration here in our codes, assuming that you have a variable that contains the URL domain of the server, all you need to do is to change it to localhost. So for example here, we are going to change from api.themoviedb.org to localhost assigned with the port number. And because we are using localhost, we will be using HTTP instead of HTTPS. Okay, so after L and A is the letter I. So I is info plist. Because we are using HTTP localhost server, we will need to patch our info plist file to allow HTTP request. So under the app transport security settings, for iOS 10 and above, you need to simply add NSAllow local networking with Boolean value to yes. And for iOS 9, you will need to add localhost as an exception domain item in your info plist. So lastly, LAI, the last letter is M. We're going to set up our mock responses based on the API being used in the test case. So this is an example how mock response setup may look like in your codes. In our test function, where we have our test codes, using the localhost server, we're going to call the route function and specify that whenever it gets a get request of path3 movie popular, we are going to return the contents of this JSON file, movie popular. Okay, and that's it. We are all ready to use the steps LAIM to set up our very own localhost-based test. But we can actually go further than that. So one of the interesting features of using localhost is that we can also assert outgoing API requests. So let's assume that we want to describe a use case for bookmarking an item on a shopping app. So in this hypothetical use case, we will start off on a listing view, and here the app fires a request to fetch items to be displayed on a table view. So when we select a row, the app will navigate to the details page. Upon screen load, the app fires another request to fetch detailed information on the selected item. And on this screen, the user can tap on the heart icon to like the item. And here the app fires another request to bookmark the item. So in this use case, we expect these 3 requests fired from the app and to be received by the localhost server. We can use the Swift localhost library to write tests to make sure these requests are being fired in this order, no more, no less. So the localhost server class records all received URL requests. This is the snippet of the localhost server definition. It has a public var called recorded request, and it records the URL request being fired from the app. In our test, we will inspect this variable to set up our assertion statements. We can specify and assert the order of request just by the URL path in being used in our test. Here we have an expected string array with first item of path 3 movie popular, second item of path verify password, and the third one get account info. And next we inspect the actual recorded request path, and then we assert that both expected and actual request paths are the same. We can also represent requests as curl commands in string format in this way. So do take note for the second and third item, we are also asserting the HTTP body contents in the request. And then we create the expected curl strings, and we assert that the actual curl strings matches what was expected. So using this technique, we can also verify analytics events. So in this test case, we are going to introduce GA request logging server that performs just like the localhost server. In the setup function, the GA request logging server also requires the same setup as the localhost server class. Similarly, in the assertion step, we will create a GA logging report object that contains the ordered list of Google Analytics events. Here, we are expecting 2 items in the report. The first is of screen view. The second is an event object with category action label values. And next, we will assert that the actual logged event matches what was expected. So now let's take a look at the demo codes. So instead of writing my own app just for this talk, I searched GitHub for a project that doesn't have tests so that I can show all of you how easy it is for any developer to write localhost UITest on your projects or even legacy codes. So special thanks to this person, Mohammed, for giving me permission to use his GitHub repository. So the first link is his the original GitHub, his GitHub project, and the second is the forked project, which I'll be demoing to you guys right now. Okay, so this is the this is the project. So let me just run the app to show you what the app is doing. So here, for this app. For this app, this is a simple movies app where you can browse through the movies and look at the details of the movies. And here we are shown popular movies, upcoming movies, top rated, and movies now playing in the cinema. So the movies are displayed on a collection view cell. In each cell, a movie is represented by its movie poster. If we tap on, let's say, Bumblebee, and then we come to the details page where we see the title, release date, and the synopsis of the movie. So that's the basic feature of the app which I've forked from. And here I'll be introducing an additional feature. I would like to, for my app, I like to introduce a login feature. So I'll be using file-based authentication. So when I tap on login, I'll be presented a login page. So let's try to register some credentials and log in. So I just type iOS.conf@gmail.com, and just password will be iOS.conf, and then register. Okay, registration success. Let me try to log in. iOS.conf@gmail.com. Okay, login is a success. Okay, the next feature I've added into this project is analytics. So let me show you the login view controller. Put this away. So in here, I'm using Google Analytics. Upon loading showing the login view, the login screen, in the view did appear, the app will be firing a screen view event of screen name login. And upon tapping on the login button after filling out our email and password, the app will be sending out an event of category login module, action tab, and label login button. Cool. So you'll be asking me, hey Kenneth, since we are using file-based authentication, how am I able to mock this service? Because I don't even know what's the request. I don't even know what's the domain. So here is a little trick for you guys to see. I've created a class, app delegate class called interceptor app delegate. So let me expand. Over here, I'm using this library called the network interceptor. Some of you guys may find this library familiar because last year in one of our Singapore iOS meetup talk, I showcased how to use this library, which I've written, to inspect all outgoing requests, including those which are SSL pinned. So in this code, this is the first part of this app delegate class. Over here, what this code is doing is that for any outgoing request, we will log the curl request, onto the console. So let me bring up the console, and let me look for the email that we just created. iOS.conf. So this is the curl, the request that was fired from the app, and this request Oops. And this request, is this the one? Yeah. This request is hitting this domain, www.googleaps.com. This is the Firebase Authentication Production API. And as you can see the payload of email, password, and one more key here, return secure token. So for now, all we have to do is just copy this curl command, go open up Postman, and we fire this request. Yeah. So here we receive status 400 response because the email that we just fired, we are basically replaying that request. Hence, Firebase Authentication is telling us that, hey, the email already exists. So now I'll go back to the body. Let me change just change one letter from I to X. Now let me send this request. And now we're getting status 200. So to create a mock response, all I have to do is copy this JSON contents, go back to Xcode, create a JSON file, and paste the contents of what we got from the Postman over here. And that's how you create your response file. Now, let me run through the steps of LAIM to set up the localhost testing. So the first letter is L. Let me go back here. The first letter is L. In our test case, we have two servers, our localhost server and our GA request logging server. And then we do the necessary setup and call the function start listening for both of these servers. That's L. For A, I've just now, oops, maybe I forgot to show you guys. So back to this file. So this earlier part is where we are able to inspect all outgoing requests. In the second part, this is the redirection code. So what this code does is, for any outgoing request that's going to hit www.googleaps.com, instead be redirected to localhost and to be assigned with this port number, which will be provided by our XD test, passed in by our XD test case. So, and the second part is the same thing, but for all SSL Google Analytics requests that is being fired from the app, we will be also redirecting to our codes. And this is actually the domain for firing the Google Analytics events to GA server. So if I go back into our console, let me look for. So over here, this is the actual request. It's actually a GET request that the app fires to tell Google Analytics that, hey, please register the following event of category login module. Label is login button, and action is tabbed. Yeah. Okay, so I've covered L and A. Go back to this. And for I, which is we need to patch our info playlist. So we go to our info playlist over here. Info playlist over here. Then for iOS 10 and above, you need to allow local networking. For iOS 9 and below, you need to add localhost as an item in the exception domains. And lastly, after LA and I is the letter M for mock. So in our test function, we are going to declare all the mock, for all these request paths that the localhost is going to receive, we are going to return the following responses of this file: home popular. When it hits verify password, we be returning response from this file. Similar for this declaration. So the LAI. So next, we need to pass in the port number that we have created for our servers into the app, so that the app knows when it hits, knows that to change the domain to localhost and to use which port number. And following, we will be writing our UI test code. And over here, what it's trying to do is go to the login screen, and in the password field, in the email field, we're going to enter the value apple@gmail.com. In the password field will be password, and then we tap on the login button, and we expect that login is successful, and we see the login message, login success. And here we can go further. We can assert our request by just specifying our expected URL path. Or we can actually put out the whole curl command, where over here we can actually assert the following JSON body that's going to be sent to the server. If you want to go further, you can also assert the Google Analytics events to be that will be fired out from the app. Here, the first item is screen view of login value of screen name login, and for the event, when you tap on the button, we are sending these values for the category, action, and labels. Okay, so let me run the test to show you how the localhost testing will look like. Yay, so now our test passed. Oh, yay. So this is, so as you can see, you don't really have to do a lot of setup. Just set up your response file, just create your localhost property, and then you can easily create localhost tests straight in Xcode. Now let me return back to my slides. So the closing, localhost test is meant to complement but not replace end-to-end tests. If you have a QA team, testing team that's working on doing some testing, you still need the effort to help you test the app. For us as developers, all we need to do is to make sure that when the QA team runs the test, it's never an iOS bug, because we can always mock our server dependence and all our dependencies to write our tests to test our features. UITest with localhost can cover almost, or if not all cases. Here, developers should be the owners of the localhost test, because only developers are aware of the API details schema that the app uses. So here in SP Digital, we put great emphasis on localhost testing. It simply took me like a few hours to create one localhost test and a simple POC, proof of concept. And then it took the team within weeks to create our integration localhost UI automation test suite. As long as the dependencies are working as expected, having UI localhost test gives us plenty of confidence to roll out releases, because we are able to automate almost all of our use cases. So here I encourage fellow iOS developers to start writing UITest with localhost. So what's next? So work on the Swift localhost library isn't complete, because I feel there might be a need to provide support for WebSockets, like for chat applications, and probably for push notifications as well. So feel free to catch me during the break. I'll be stationed at the SP booth during the break. Yeah. So here are the references for this talk. Yeah, and here's the slide share. So if you want to get a copy of these slides, just go to this link. Yeah, so I'm happy to take questions from the floor.
Hi, thank you, Kenneth. Yeah, you can take a look at these questions.
Number one, how do you mock things like download image or video? So the question I want to put to ask to give to the person is how it is possible to mock an image, because all you have to do is you can set up the data, I think the data object on how you, in the response of the, when a path comes in, you can actually return the data contents of the image file, but of course you need to specify your HTTP headers of the response. So here, for video, I probably have not able to do that right now. So I might be exploring things like WebSockets in order to fulfill this question. Okay. So the next is, what is the benefit of using this approach over the Moya stub testing? There we can also add behavior for delay in APIs. So I think this is to, okay, so the idea for this is, as when we test UI, we don't want to actually modify the actual app binary. All we want to do is to just change the domain to localhost, and we should be able to write our test and run our expectations. So if we are doing stub testing, where we put the responses into the app, we are missing out on hitting the HTTP layer, TCP layer, which the app actually does in production. So what we really want to do is to mock the app firing out the request instead of hitting the stub objects. So now the third one, how we keep between our localhost server and the real server in sync? Good question. So maybe you can put on this phone. So let me go back. Go back to the slide. So I mentioned over here that we have two kinds of tests, integration tests. So what I described here is mock response test. To ensure that everything is in sync, as developers, we need to write tests to basically check that the definitions, our contracts don't change. The contracts that the app uses to communicate with the server doesn't change. So here at SP, we actually, we call it the mobile contract test. What we do is, assuming this test case, this use case, and we know that the app will be firing this request, we write tests to curl the servers and to check whether the server is returning this response with this schema and with these details. If, for example, we are sending rubbish, we expect status 500 with an error message. And so we are running this here at SP Digital. We are running this frequently to ensure that whenever there's change in the server, the contracts, we will be notified, and we will take a look and see whether we need to actually update our UI test codes.
Thank you, Kenneth. I think for the remaining questions, Kenneth is still reachable, as he mentioned, at the booth, as well as over Slack. So yeah, one more round of applause for Kenneth.